In 2013, Voyager 1 achieved a historic milestone by becoming the first-ever human-made object to enter interstellar space, accomplishing this feat 36 years after its departure from Earth. The space probe now resides an astonishing 14.5 billion miles away from Earth. As a result, the transmission and reception of messages require nearly 2 days, specifically 20 hours and 33 minutes. While NASA's engineers never could have anticipated that Voyager 1 would continue its space exploration for nearly half a century, the sophisticated instrument has done it again. This time, it has detected 500 unidentified objects passing by in space. Now, world-famous podcaster Joe Rogan has joined the conversation, shedding light on the alarming implications of this extraordinary discovery. What are these mysterious objects? Could they be the handiwork of extraterrestrial beings or a malfunction on the spacecraft? Join us as we explore how Voyager 1 detected 500 unknown objects passing through space and discover Joe Rogan's thoughts on this astounding discovery. Ever wondered why, despite the unimaginable vastness of the cosmos, we haven't stumbled upon concrete proof of advanced extraterrestrial civilizations? This dilemma is called the Fermi paradox, and it has been a captivating mystery for scientists for centuries. However, a recent extraordinary encounter in deep space has sent shockwaves through the scientific community, potentially shedding light on the age-old question of the existence of aliens. Joe Rogan, a prominent commentator and podcast host known for his keen interest in discussing aliens and the possibility of advanced civilizations, has previously hosted guests such as David Grush and Avi Loeb to explore the potential for life beyond Earth. Now, new data from Voyager may first hold the key to answering the question of whether we are truly alone in the universe. Buckle up as we will expose why Joe Rogan's announcement about Voyager 1 detecting 500 unidentified objects passing through space is a game-changer and how it affects you regardless of where you are in the world. But before we get into those juicy details, let's find out how the groundbreaking Voyager 1 mission was born in the first place. Isn't it mind-boggling to think that our magnificent Earth, with its vast oceans and towering mountains, is just a tiny speck in the grandeur of the universe? Philosophers have pondered this fact for centuries, but it wasn't until the 1970s that NASA scientists had the opportunity to truly grasp the scale of our cosmic neighborhood. And it all began with an accidental alignment of Jupiter, Saturn, Uranus, and Neptune, the 4 largest planets in our solar system. In the midst of this celestial dance, a young PhD student named Gary Flandreau, working part-time at NASA's Jet Propulsion Laboratory while pursuing his studies at the California Institute of Technology, stumbled upon a remarkable discovery. Through his meticulous calculations and charting of the orbital paths of these giant planets, Flandreau unearthed a celestial phenomenon that would change the course of space exploration. What Flandreau found was simply awe-inspiring. In the late 1970s and early 1980s, the 4 planets would align in a mesmerizing formation, resembling pearls on a cosmic necklace, with Earth nestled among them. This discovery sent ripples of excitement through NASA, as it presented an unprecedented opportunity to optimize the trajectory of a space probe. By cleverly utilizing the gravitational pull of each planet during flybys, a spacecraft could harness a speed boost, akin to being tugged by an invisible cosmic cord that propels it forward. Flandreau's estimations suggested that these gravity assists from the giant planets could shrink the flight time between Earth and Neptune from a daunting 30 years to a mere 12 years. But there was a catch: this celestial alignment occurred only once every 176 years. Recognizing the significance of this once-in-a-lifetime opportunity, NASA embarked on an ambitious mission to capitalize on the planetary alignment. 2 spacecraft, christened Voyager 1 and Voyager 2, were developed with identical designs and purposes. Launched just 15 days apart in the summer of 1977, these twin explorers were set on a course to unravel the mysteries of the solar system and venture into interstellar space. Voyager 1, launched on September 5, 1977, became an integral part of the Voyager space program, a testament to humanity's insatiable curiosity and our quest for knowledge. For nearly 5 decades, this brave traveler has forged ahead, beaming back invaluable data to Earth through NASA's Deep Space Network. It has become our eyes and ears in the vastness of space, bridging the gap between our terrestrial existence and the mysteries that lie beyond. As we marvel at Voyager 1's extraordinary journey, it's worth noting that its distance from Earth is nothing short of mind-blowing. As of August 2023, the space probe is situated an astonishing 24 billion kilometers away, making it the farthest man-made object from our planet. It was meticulously designed and constructed by the brilliant minds at NASA's Jet Propulsion Laboratory and embarked on its historic odyssey from Launch Complex 41 at the Cape Canaveral Air Force Station, propelled by a Titan IIIe launch vehicle. Just when you thought you'd seen it all, the recent revelation unfolded. Now, let's delve into the remarkable expedition that led to the discovery of 500 previously unknown objects passing through space and the fascinating revelation Joe Rogan provides in a recent episode of the Joe Rogan podcast. How did Voyager 1 successfully journey through space? And what special scientific instruments and subsystems were behind such success? Imagine a man-made space explorer venturing into the great unknown, conquering the forces of deep space for decades and decades again. That's Voyager 1 for you. This brave spacecraft has already journeyed a mind-boggling 14.5 billion miles away from our home planet, Earth. Just try to wrap your head around that for a moment. It's like traveling a distance that is approximately 3.6 times the span between the Earth and the Sun every single year. But Voyager 1 is not just about its velocity, longevity, and distance. It has also gifted us with groundbreaking revelations, including its recent discovery of 500 unknown objects lurking out there in the vastness of space. These celestial entities are like nothing we've ever seen or identified before. It's a cosmic treasure trove of mysterious wonders, and we're about to dive into the details of this awe-inspiring revelation. Now, you're probably wondering how a spacecraft that was launched way back in 1977 can still be operational and deliver such mind-blowing information. Well, the answer lies in the remarkable engineering and foresight that went into Voyager 1's design. One of the key secrets to its longevity is the presence of dual redundant computer systems. Both Voyager 1 and its twin, Voyager 2, were equipped with two sets of command computer subsystems, the Flight Data Subsystems, FDS, and the Altitude and Articulation Control Subsystems. This redundancy was a stroke of genius, ensuring smooth transitions between systems and the ability to activate dormant computer components when needed, effectively extending their lifespan. The computer systems aboard these Voyager spacecraft were organized as a distributed system, with three dual redundant pairs of computers. This clever arrangement ensured that even if one system failed, the other could seamlessly take over, preventing any mission-critical failures. To make the most efficient use of limited power resources, Voyager's instruments relied on hardwired logic. In other words, the computer systems were designed with simplified, hardwired circuits that operated within the constraints of power budgets and time limitations during the spacecraft's development. Power management is a crucial element for maintaining the operational integrity of Voyager 1. You see, the spacecraft's distance from the Sun, where it can harness solar energy, poses a significant challenge. To maximize power efficiency, engineers had to come up with innovative ways to conserve and optimize power usage. And let me tell you, their strategies are truly extraordinary. Selective power shutdowns of non-essential systems play a pivotal role in power management. Engineers meticulously evaluate which components or subsystems are not vital for the primary mission objectives. For example, heaters associated with certain scientific instruments have been deactivated. Originally meant to maintain instruments at specific temperatures for optimal performance, these heaters, when turned off, significantly reduce power consumption, thereby extending the spacecraft's overall lifespan. But don't think for a moment that the decision to power down non-essential systems is taken lightly. It involves careful evaluation of the trade-offs between power conservation and the scientific objectives of the mission. Engineers work hand-in-hand with scientists to ensure that deactivating specific systems doesn't compromise the quality and availability of scientific data. The goal is to strike a delicate balance that maximizes power efficiency while maintaining essential functionality. And here's the really fascinating part. Voyager 1's power management strategies adapt to the changing conditions of its environment. As the spacecraft journeys farther away from the Sun, the available solar energy decreases. But fear not. Voyager 1 adjusts its power usage accordingly, ensuring that the available resources are efficiently allocated to support critical operations and data transmission. It's like a smart energy-saving mode that kicks in automatically. Over the years, there have been remarkable technical advancements and improvements in power management techniques. Engineers have honed and optimized the power systems of the Voyager probes, implementing upgrades such as more efficient power distribution, improved battery charging methods, and advancements in power regulation and control. Thanks to these meticulous power management strategies, Voyager 1 has defied all expectations. It keeps on going, still sending back invaluable information almost half a century after its launch. When you consider that this space traveler was initially designed to last a mere 5 years, its enduring mission is nothing short of astonishing. It speaks volumes about the dedication and skill of the scientists and engineers who have worked tirelessly to keep Voyager 1 operational. But let's not forget that the depths of deep space are full of surprises. So, hold on tight, because a major discovery is right around the corner. The Voyager missions aimed at exploring the vastness of the solar system and beyond were equipped with an impressive array of scientific instruments, suites, and subsystems. These instruments were strategically placed on the spacecraft's body, which itself consisted of a staggering 65,000 individual parts. While the Voyagers embarked on their interstellar journey with numerous functioning instruments, only 4 remain operational on Voyager 1, and 5 continue to work on Voyager 2. One of the enduring instruments on both Voyager 1 and Voyager 2 is the low-energy charged particle detector. This instrument boasts 3 sets of particle sensors that measure the number of low-energy particles that strike it, as well as their speed. It diligently observes cosmic radiation and particles originating from the Sun, the planets, and interstellar space. A companion instrument, the Cosmic Ray Instrument, actively seeks out highly energetic particles from both the Sun and other galactic sources. Presently, the Cosmic Ray Instrument is engaged in detecting the abundance of particles within the protective bubble exerted by our Sun's influence, as well as particles emanating from the vast expanse of interstellar space. These readings have proven crucial in determining the moment Voyager 1 crossed into interstellar space. Remarkably, this instrument remains operational on both Voyager 1 and Voyager 2. The plasma wave subsystem, featuring 2 elongated antennas positioned at right angles to each other, serves as a vital tool for measuring the electrical field components of potential waves encountered at the outer planets. However, its role has evolved as the Voyagers ventured into interstellar space. Today, this instrument provides valuable insights into the changes experienced by plasma waves as they transition into the realm of interstellar space. Notably, it continues to operate on both Voyager 1 and Voyager 2. Initially designed to investigate the magnetic fields of the outer planets, the magnetometer now plays a central role in the search for the transition region between the interplanetary and interstellar media. Scientists utilize this instrument to explore the magnetic characteristics of the transition region, located at the boundary where the Sun's magnetic influence interacts with and gives way to the magnetic field of interstellar space. Remarkably, the magnetometer remains functional on both Voyager 1 and Voyager 2. Another instrument of significance is the Plasma Science Instrument, which meticulously examines the lowest energy particles within the plasma. It possesses the capability to identify particles moving at specific velocities and, to a limited extent, determine their point of origin. These features become increasingly crucial as the spacecraft ventures deeper into interstellar space. However, it is important to note that this instrument is presently operational solely on Voyager 2. While certain instruments aboard the Voyagers have ceased functioning either independently or by intentional shutdown to conserve power, the Plasma Science Instrument on Voyager 2 stands as a testament to the ongoing scientific exploration. Additionally, to preserve power, NASA has systematically deactivated heaters on both spacecraft. In 1998, after 21 years of operation, non-essential instruments were permanently turned off. The power source for each spacecraft consists of 3 radioisotope thermoelectric generators, RTGs. These generators utilize the heat produced by the radioactive decay of plutonium-238 to generate electricity. However, as the plutonium-238 continues to decay, it will eventually no longer be able to provide power, leading to the cessation of all instrumentation. This is expected to occur around 2025. Nevertheless, the Voyager team is employing meticulous power management techniques, aiming to prolong the operational lifespan of both spacecraft until 2027, coinciding with the 50th anniversary of their launch. Each Voyager probe is equipped with a pair of thrusters, not for propelling the craft forward, but for reorienting it so that its antenna consistently points towards Earth. This alignment is crucial for maintaining communication with the spacecraft. The thrusters emit brief pulses, or puffs, lasting mere milliseconds, to subtly rotate the spacecraft and direct its antenna towards Earth. In November 2017, due to the degradation of Voyager 1's primary thrusters, scientists activated the backup thrusters after nearly 4 decades of dormancy. This action ensured that Voyager 1 maintained its lock on Earth. Remarkably, despite their extended period of inactivity, the backup thrusters sprang to life, successfully reorienting the spacecraft's antenna. The main transmitter on the Voyager probes emits approximately 20 watts of power, akin to the illumination of a typical refrigerator light bulb. By the time the signal from Voyager reaches Earth, its strength has diminished to a staggering 20 billion times weaker than that of a digital watch battery. It is worth noting that your iPhone has 100,000 times more memory than the Voyager spacecraft, despite the spacecraft's high-tech capabilities at the time of its launch. Now you have a good idea of the Voyager missions. Fasten your seatbelts as we delve into the mysteries surrounding the recent discovery of 500 unidentified objects in space. Could the data sent by Voyager 1 be a malfunction? And has Voyager 1 previously experienced a malfunction? Voyager 1 has once again captured the attention of the scientific community with its recent discovery. The space probe has stumbled upon a remarkable find: 500 unknown objects lurking in the depths of space. This revelation has sparked a wave of concern among researchers, as these mysterious objects remain largely enigmatic. Adding to the intrigue is the fact that the initial data transmitted back to Earth was a chaotic jumble, resembling a garbled message from the cosmos itself. Just imagine the astonishment on the faces of the scientists at NASA's Jet Propulsion Laboratory when they realized they were receiving these perplexing signals from the far reaches of space. After a thorough investigation, they traced the source of the confusion to the Attitude Articulation and Control System, AACS. The AACS is an essential component on board Voyager 1, responsible for measuring, reporting, and adjusting the spacecraft's position in space. Equipped with an antenna pointed towards Earth, the AACS enables the transmission of data back to our planet. Scientists soon discovered that the AACS had inexplicably switched to using a faulty onboard computer that had been dormant for years, resulting in distorted telemetry data. NASA engineers promptly resolved this issue by reconfiguring the AACS to transmit data through the correct computer. Consequently, uncorrupted data from Voyager 1 is now flowing once again to NASA's eager scientists. However, the question that lingers in everyone's mind is, what prompted the AACS to make use of the malfunctioning computer in the first place? While NASA scientists have yet to provide a definitive answer, they have proposed a hypothesis suggesting that the AACS received an erroneous command from another onboard computer. Nevertheless, the specific computer responsible for this anomaly and the nature of the fault remain uncertain. Suzanne Dodd, the project manager for the Voyager interstellar mission, shed some light on the situation, revealing that a comprehensive memory readout of the AACS will be conducted, followed by a thorough analysis of its operations. This meticulous approach aims to diagnose the root cause of the telemetry issue. Importantly, NASA's Jet Propulsion Laboratory has emphasized that the AACS itself appears to be functioning properly, and none of the spacecraft's fault protection systems have been triggered. Consequently, Voyager 1 has not been compelled to enter safe mode, and its signal strength remains unimpaired. While numerous factors could contribute to this anomaly, one plausible consideration is the extreme environment of space. The cosmic realm is notorious for its harsh conditions, which can pose significant challenges to the operation of a spacecraft such as Voyager 1. The electronic systems on board can be susceptible to disruptions caused by cosmic radiation and dramatic temperature fluctuations. Cosmic radiation comprises high-energy particles originating from distant stars and celestial bodies, capable of penetrating spacecraft structures and inducing electrical disturbances, data signal distortions, memory errors, and data corruption. Furthermore, temperatures in the outer reaches of space can plummet to a bone-chilling -202 degrees Fahrenheit -130 degrees Celsius. Additionally, Voyager 1 is exposed to micrometeoroids, dust particles, and fragments from asteroids and comets, which can exert a profound impact on its functionality. As the spacecraft ventures into interstellar space, its plasma wave instruments have consistently detected the impacts of dust particles. Due to its high radial velocity of 17 km per second, when a dust particle collides with the spacecraft, it instantaneously vaporizes and ionizes, generating an expanding plasma cloud that triggers a voltage pulse in the electric antenna of the plasma wave system. These energetic collisions with interstellar dust grains have the potential to inflict damage upon Voyager's delicate systems. Although unconfirmed, the presence of interstellar dust particles may explain the peculiar data transmitted by Voyager 1. While all these factors could contribute to the malfunctioning of the spacecraft's computer systems, it would be inaccurate to attribute the root cause solely to these occurrences. Why is Joe Rogan so excited about this recent discovery? And what does it have to do with aliens? Scientists have put forth various natural theories to explain the glitch in Voyager 1's system, but there's one possibility that captures the imagination and belongs in the realm of science fiction: the involvement of extraterrestrial beings. Now, it's important to note that this theory is highly speculative and not widely accepted in the scientific community. It's more of an exciting concept than a well-founded scientific hypothesis. However, let's embark on this cosmic adventure and explore the possibility. The concept of intelligent extraterrestrial life has long fascinated scientists and space enthusiasts alike. Joe Rogan, a popular podcaster and media personality, has delved into this topic through his conversations with researchers and UFO enthusiasts. In particular, he has spoken with David Grush, a former Air Force intelligence officer and representative of the National Reconnaissance Office to the Unidentified Aerial Phenomena Task Force, who provided insights on hidden information about aliens. Additionally, Avi Loeb, an eccentric scientist, discussed the existence of extraterrestrials during his appearance on the show. These discussions have added fuel to the flames of curiosity surrounding Voyager 1's malfunction. Joe Rogan believes that the universe is vast, with billions of galaxies, each containing billions of stars and potentially even more planets. In this vast cosmic ocean, the statistical likelihood of other life forms existing is high. The idea of intelligent civilizations elsewhere in the cosmos raises thrilling questions about their potential interactions with us, Earthlings. Is it possible that these extraterrestrial beings, if they exist, stumbled upon Voyager 1? Perhaps they noticed our spacecraft as it traversed the cosmos and, out of sheer curiosity, decided to investigate. It's akin to encountering an alien artifact from another world. This scenario proposes that the glitch could be their way of sending a cosmic message, a form of interstellar hello. This notion also leads to the tantalizing possibility that these hypothetical extraterrestrial beings discovered the Golden Record, an extraordinary artifact aboard Voyager 1. The Golden Record is like a cosmic message in a bottle, containing sounds, music, greetings, and images from Earth. It serves as an interstellar time capsule, intended for any intelligent life that might come across it. If alien beings managed to access the Golden Record, they would be decoding a wealth of information about Earth's cultures, languages, and the remarkable diversity of life on our planet. This raises profound questions. How would they interpret our music and art? What might they think of our languages and scientific knowledge? Nonetheless, it's crucial to emphasize that the idea of extraterrestrial involvement in Voyager 1's glitch is highly speculative and lacks scientific evidence. The glitch could be attributed to natural factors we explored earlier, such as cosmic radiation, extreme temperatures, or micrometeoroid impacts. While the search for extraterrestrial life is an active area of scientific inquiry, and astronomers continue scanning the heavens for signs of otherworldly existence, the notion of alien tinkering with our spacecraft remains largely in the realm of science fiction. Fortunately, engineers have successfully resolved the issue affecting data transmission from NASA's Voyager 1 spacecraft. After an extensive investigation, the team identified the root cause. The AACS had started transmitting telemetry data through an inactive onboard computer, leading to data corruption. To rectify the problem, Suzanne Dodd, Voyager's project manager, and her team took a low-risk approach. They instructed the AACS to redirect the data to the correct computer, effectively resolving the garbled transmission. While engineers have yet to determine why the AACS began sending telemetry data to the wrong computer, they suspect a faulty command from another onboard computer might be the culprit. However, this remains a hypothesis, and further analysis is required to pinpoint the exact cause of the anomaly. Despite the temporary hiccup, Voyager 1 continues to function well, and its scientific instruments remain operational. The spacecraft has provided invaluable data about our solar system and interstellar space, and scientists eagerly await the next set of discoveries as Voyager 1 ventures deeper into the cosmos. As we celebrate the successful resolution of the telemetry issue, let's reflect on the remarkable journey of Voyager 1. Launched over 4 decades ago, this intrepid explorer has defied the odds, surpassed all expectations, and continues to push the boundaries of human exploration. Whether unraveling the mysteries of our solar system or encountering unexplained phenomena in the depths of interstellar space, Voyager 1 remains a testament to humanity's insatiable curiosity and our quest to explore the unknown. While the recent glitch in Voyager 1's telemetry data sparked excitement and speculation, it ultimately highlights the challenges of deep space exploration and the resilience of our space probes. As we look to the future of space exploration, with missions to distant worlds and the search for extraterrestrial life, the legacy of Voyager 1 serves as a guiding light, inspiring future generations to reach for the stars and unlock the secrets of the cosmos.